Good morning, everybody. So we are going to finish up comparing means, which is chapter 24. We're on day 3. So if you recall from two proportion z-tests, when we were able to do pooling. Let's talk about that a little bit. Remember that when we know a proportion, we know its standard deviation because the standard deviation formula is p times q over n square root. When testing the null hypothesis, when two proportions are equal, we could assume their variances were equal as well. So if the null hypothesis is equal, that both items are equal, we can say that the variances are equal. This led us to pool data for hypothesis testing. For means, there is also a pooled t-test. However, in this class, super important, we are not going to pool. There is no link between the mean and the standard deviation. That would be a great multiple choice question, but of course, we don't have multiple choice. So like two proportion z-test, this test assumes that variances in the two groups are equal. That assumption is like extremely rare. So to say that there is variances that are equal amongst means would be very rare. So if you're willing to assume the variances of two means are equal, you can pool. But here's what I'm going to say right now. I'm going to blow through some of these pages right now, is that in this class, you are not going to pool for means. So let me show you on the calculator. On the calculator, when we were doing two sample t-tests, there was a choice after we went through all the work to say pooled, and I always said just choose no for right now. The reason being is it's going to be extremely, extremely, extremely rare, and what they say is that the advantages are small. So when are you going to pool? You're going to never pool in this class. Okay. Certainly when you get to college and you take some more advanced stats classes, when you take stats 2, which most of you probably will if you're business majors or if you are certainly math majors. But the advantages are small. You're only allowed to pool rarely. So don't. It's never wrong not to pool. So my point here is on this calculator where it says pooled no, keep it no. When we're doing proportions, it doesn't ask you to pool because it will automatically do the work for you. So, okay, so we're not going to ever say that the variances, we're not going to assume the variances are equal. I'm going to blow through these. Let's do a quick example. And then we will be done chapter 24, day 3. So college financial aid offices expect students to use summer earnings to help pay for college. But how large are these earnings? One large university studied this by asking a random sample of 1,296 students who had summer jobs how much they earned. They were separated into two groups based on gender. Is there a difference in the amount males and females earn? And of course, from our standpoint, we're talking about a statistical difference. When I see is there a difference, I'm thinking is there evidence in a difference? And that's going to make me think we're going to do a test. So the following stats are calculated from the gathered data. So there's the males and females, what their mean salaries were for the summer, and what their standard deviation was in dollars. Okay, so let's begin. We're going to be doing phantoms. So I'm going to kind of write that down so I remember it. In this case, let's make a note right now. I can see that the males are making more than the females, so I'm going to call the males my mu1. Let me put it to mu1, and my females are going to be my mu2. Okay. So that way, I'm always going to have, it'll be a positive number that we're looking at. It'd be fine either way. You just need to be able to say it in the final terms. Is there a difference in the amount of males than females earn? Okay, fine. So our null hypothesis, and again, if you want to move ahead, you want to pause this, do the work, and then check your work, that would be great. Null hypothesis is going to be mu1 is equal to mu2. The alternative hypothesis, that should be an H. I don't know why I wrote a mu. The null alternative hypothesis is going to be mu1 is not equal to mu2. Don't forget that mu1 minus mu2 is equal to 0. Mu1 minus mu2 is there a difference? Is all it's asking is not equal to 0. Okay, it's not asking if they make more, it's just asking if there's a difference. Got it? Okay. So H, so now we're on the A, assumptions and conditions. Let's talk about the assumptions and conditions. Let's circle some things. It is random. Males and females are independent groups, right? I realized that they said gender, not sex, but a male cannot be a female in the case of statistics, okay? We're keeping it very, very clinical. All right. Third thing, less than 10% of the population. I realize it's just a random college, and we're talking about what, but it's a large university. Large university, I'm thinking something like Ohio State, 40, 50, 60,000 people, even 30,000 people. It's a big school, so therefore it's less than 10% of the population. And the last one is the nearly normal. Large, this is a large sample, over 40. So because the sample is large, we are going to say that it is going to be, we're allowed to use the nearly normal from the central limit theorem. So it is nearly normal because of the large sample size. Okay. That would be the only thing I'd be a little concerned about, is that they didn't give us anything to do it with. Okay, so let us go for doing our data. So let's go to our calculator. I'm actually already on a 2-sample t-test. Go ahead and get there, and let's put in our data. So mu1 is going to be 1884.52. Standard deviation is 1368.37. Number was 675. Second one, 1360.39. So again, we can see that it is much smaller. Yeah, girls making less for one reason or another. Just so you know, when I was in high school and college, I made a lot of money in the summer while I'm typing everything in, because I was a waitress, and waitresses make a ton of money in tips. Not a ton, I mean, but I always felt I was doing pretty well for myself. Working in retail, not so much. So I hated doing retail, period. I didn't like retail. I liked being a waitress. I liked talking to people. I liked being busy. Retail, I felt like I was standing around all the time. It's just me. But if you can ever have a job with tips, that's where you can make a lot of money quickly. Not equal to. Pooled, no, and I'm going to calculate. So what do we get here? Wow, we have a huge t-value, 7.8. P-value is to the negative 14th power. Wow. And then our degree, not power, but to the scientific notation, and our degrees of freedom is 1249. Okay, so let me write this stuff down. So I would do, so I'm sorry, that's right, all conditions. Let me write it. Okay, sorry. All conditions that use 2-sample t-test. I'm also going to have an alpha level equal to 0.05. Okay, so our t-value was 7.8. Our p-value was, I don't want to do it. Gosh, it is so small. I'm going to write almost 0. If you feel uncomfortable with that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, of course, 14. That should do it. Almost 0, and that's what the 0 is. Okay, fine. So we can now go we obtained our p-value, make an assumption because the p-value is almost 0 and smaller than the alpha level of 0.05, we can reject the null hypothesis that they're equal, period. There is strong evidence that that there is a difference in male and female earnings in summer jobs. Okay, and that's all. Excellent. You guys have a wonderful day, and I will have a video up on Friday. Have a good day.